1 second. We'll get going. Okay, yeah. Okay, I think we are good here. All right, so good morning, everyone. Happy Tuesday. Let's kind of get started here. First, I just wanted to check. Maybe I'll put it in the polls here. Can you all, wait, did I launch it? No. There we go. Can you all hear and see me? Just want to do a quick audio video check with everyone. Okay, I see a whole bunch of yeses. So, you know, if there's a no, it's probably an individual. So looks good. Okay, but you got to do that in the poll because, you know, if you can't hear me, you can't hear what I'm saying. All right, so quick, yesterday we kind of had that, you know, snafu. I tried to do like a fun class from Central, but the connection there just would not have it. So, you know, kind of abandoned ship on that. But I did want to spend just a little bit of time showing some of that stuff because I know that it's important to kind of show. I'll just go quickly through the Canvas page because I want you all to see that stuff. I did post in the afternoon. Those uploads are pretty slow. I did post an introduction to differential equations, and that's in Panopto, and I'll show you where that is when we get there. And then today, after all that stuff, the logistics, we'll do kind of a talk about separation of variables, and then at the end of class, we'll just do a quick icebreaker type thing. I'm going to put you all in breakout rooms just for just a couple minutes here. But first, let's go to, I think to do this best, what we want to do is switch cameras. Front. Oh, okay, well, that's fine, because I'm about to hit share screen anyway. That's not a big deal. Oh, wait, I just gotta go to here. There we go. And I'm just gonna turn this thing off. Okay, I think you can all see the screen I'm sharing. I just want to go real quick through the Canvas page. Yesterday, the connection just was so terrible that I don't know how much people got out of it. But an important thing here is definitely check this link right here. This has our schedule, what we will be covering each day with lecture notes. Right, if you click here, it'll download. You know, this is today's lecture notes. This is what I'll be covering. I recommend printing them out and just taking your notes on these notes, right? Oh, I see something in the chat here. Oh, come on, chat. Oh, you're looking at my email? Okay, wait. Okay, new share. This guy. Yeah, you're probably looking at my empty email box. Okay, here we go. Sorry about that. Here we go. So here's our Canvas page. Click this button right here. I was going to close my email. And these are the lecture notes with the schedule here, right? So click here, and that will take you to today's notes. Okay, that's super important. I would definitely look at those notes, you know, before class, or if you know, just along with class here. Okay, office hours are the hour before. Here's the syllabus. Projects, there'll be many projects that are Mathematica based. We'll talk about the first one later next week, I think on like Tuesday. It'll be on Euler's method, and here are the corresponding due dates, right? Most of them are going to be Mathematica based, like I said. If you want you can use another program such as MATLAB or Java or Python, and that's totally fine. You'll just want to send me the code for that. However, I'm going to do all the demos with Mathematica, and I sent that download, those download instructions, I think, in that email yesterday for Mathematica. Exams, we're going to have 3 exams on these dates, and next week we're going to have a practice exam where you'll have to simulate the exam. You'll want to, and I'll send this in a document as well, but you're going to want to have a webcam where I can kind of just see the work that you are doing, right? So it'll just need to show your area that it is free and clear of stuff. And you can either do your exam printed out or on a separate sheet of paper and then scan and send it to me. But again, we'll talk more about that next week when we do the practice exam. Online homework and written homework are over here in the assignments tab. Reading assignments through WAMAP, online homework, and then the written homework is here, right? So online homework, you should kind of see I think online homework has unlimited attempts, and reading assignments are pretty simple. If you just kind of follow the book, you should get full credit on those reading assignments. I think there's like 2 attempts or something like that, 2 or 3 attempts per problem. Okay, let's go back to home. Wow, look how fast this connection is compared to yesterday. This is way better. Written homework also under the assignments tab. Here's the grading rubric, this stuff, and the book here, right? This guy right here, and there's the info. I will say, if you Google that textbook, it's one of the top searches as a PDF, right? So if you want to just do that for free, that's fine. Or you can buy it on Amazon. I kind of like the actual book. And here's some tutoring resources I would definitely check out here. And some more info on the Mesa Center coming up. Great. Okay, so I'm going to hit stop share and go back to this other camera. Cool. All right, so yesterday we looked, and the Panoptos are there too. If you just click the Panopto tab, it's pretty straightforward. And there was a Slack group that was created, I saw in the chat yesterday. If someone has the link to that, they can share that. Otherwise, I'll dig that out and send that in a message. But if I see it show up in the chat, that would be awesome. Okay, so what we saw yesterday was kind of the basics of differential equations, right? We saw a differential equation is an equation that has some sort of derivative in there. And what we're doing is solving that differential equation. Now, something I want to add that I did not mention yesterday. Where's my eraser? We can get rid of this because class has begun. Notice I think this was the example from Panopto from yesterday. dy by dt equals t, right? This was our differential equation here. Now, our solution, I think the solution that we had was y equals 1/2 t squared. This was one of the solutions, right? We had a few other solutions, like t squared plus 5 and t squared plus 6, or 1/2 t squared plus 5, 1/2 t squared plus 6 are all solutions. But what I want to mention here, what makes this different from a normal equation, I'm just going to formalize the notation a little bit, Notice that the solution is a function. Now, I guess I mentioned that yesterday, but I just, I showed that this is a function, right? But I didn't explicitly mention that, right? That our solutions are always a function. Now, this solution is a function. Solutions can be implicit. We will eventually get to those. So an implicit solution might be something like x squared plus t squared equals 5, or maybe y, because I'm using the variable y here, right? Where it's not y as some function of t. This is an explicit solution. And for the most part, we're going to deal with explicit solutions. Explicit solutions are better because they're just a little more versatile. When y is a function of t, you can graph it a lot easier. There's only one y for every t. And we'll kind of see, this is a little bit easier. But sometimes it just has to be a implicit solution here. But always some form of either explicit or implicit solution. Not a number like 5 or 10, like a normal equation. Okay, so that's my little dealio there. Let's take a look at, let's actually, I have a different example, but let's start with this. Actually, let's go with my other example. Let's solve a differential equation with an algebraic method that we're going to use called separation of variables, right? And so let's take that over here. And this is kind of 1.2. One other thing, we will come back to section 1.1. I just do it a little bit out of order, I guess, my preference. Oh, and it looks like someone threw something in the chat, the Slack thing, so awesome. I think the way that Slack thing works, it's like kind of like a discussion board that you can share, talk, whatever, and I just don't join it. Whatever you want to say, you guys say. It's kind of outside my realm. So there you go. Okay. Separation of variables. I don't know if that's how you spell separation. I think I spelled it wrong. Whatever, it doesn't matter. I think that the E and the A should be reversed. But let's use it to solve this differential equation. I'm going to say find the general solution to this guy right here. dy by dt equals ty squared, right? So, of course, this is a differential equation because it's a equation to the equal sign, and it has a derivative in it, right? And using the method separation of variables. So here's kind of the idea. Now, later I'll talk about why this move is a little bit like fishy, or there's some issues with this method, and we're going to brush those under the carpet for now. But here's kind of the deal. First, I'm just going to distribute the square. This is nothing fishy here. I'm going to say that's t squared, y squared. And now, here's kind of the idea. Separation of variables. Well, we're going to do exactly that. I see y and y, and I see a t, and I see a t. And what we are going to try and do is put all the t things on one side of the equal sign, and all the y things on the other side of the equal sign. That's going to be kind of our mission here. So as we see, y's and t's on the left and the right. I'm going to put the y's on the left and the t's on the right. Doesn't really matter actually which side. So y's are going to be on the left. So I'm going to divide by y squared. This is like a normal algebraic method. And now this is I kind of was like warned us all about something, that this is a little fishy. I'm going to multiply both sides by dt. Right? So let's see what happens. Y's cancel, and we end up with 1 over y squared dy equals t squared dt. And what I did was I treated dy by dt like it was a fraction. This is kind of the thing that's like not so ideal. Sort of the shorthand explanation why this is like a little bit fishy is dy by dt. This is not actually a fraction, right? This is a notation that says the slope of y as a function of t. And we use a notation that looks like a fraction, right? And we kind of use this fraction thing here to multiply both sides by dt to make this work out. And I'm just going to say, for separation of variables, it's kind of okay to do this. It works like 99.999% of the time. The few times it does not work won't be in this class. That's for like upper level math analysis that's all based on proofs and stuff. You know, there's corner cases where this doesn't really work out very well. But for all intents and purposes in this class, it's going to be okay. But what I've done here is y's on the left, t's on the right, and now we can integrate both sides here, right? So notice that what we're going to end up, oh, you know what? When I go up to here, I'm going to change this a little bit too. I'll just copy this up here. All right, do this. You know what I'm going to do after class? This will be fun. I'm going to like adjust this board. Right, I'm just going to kind of like bring this out to like here, right? So that way it's like less angled, you know, so it'll be like a board like or a whiteboard like here or something like that. It'll be cool, I think, right? It'll make it a little less weird with the angle stuff. I have to write big to make it let you see what's going on here. Like, yeah, that -2, let's make that bigger. Okay, right, so y to the -2 dy, t to the +2 dt. And the reason I did this, the reason I converted this to the negative exponent from here, it makes my antiderivatives easier, right? I always get stuck with the antiderivatives. Let's do this one first. T squared. Anyone know what the antiderivative of t squared is? Or want to help me out?
T to the third over 3. There we go.
Yeah. I heard that. I heard t to the third over 3. What's missing?
Plus c.
Yeah, that's right. Plus c. Right? Cool. All right. I'm going to actually up my volume here. My volume down. All right. That way I can hear you better. Right? Yeah. So don't forget that plus c. It's going to be important. Because remember, we're looking for the general solution, and we kind of mentioned in that Panopto video, general solution is going to have a plus c in there. Okay, now this one is always harder. Y to the -2. Is that going to become y to the -1 or y to the -3?
It'll be y to the -1.
That's right, right? Can you see the temptation to say -3 though, maybe? At least I'm tempted to because I make lots of mistakes, right? Because it's like, the rule is add 1 to the exponent. But when you add 1 to -2, you get -1, which is like Yeah, that's like a mistake I make on a test. You know, you're rushed or whatever. And technically divide by -1. I'll just kind of follow the rule pretty blandly here. And okay, now I have plus C over here too, right? Now I kind of mentioned this yesterday. Constant and a constant. This is like a little bit, differential equations has this kind of fishy algebra. I'm just going to combine those into one constant on one side, right? So I'm just going to, I'll leave it here for now. And I'm just going to say, right, it just combines with that guy, right? You know, a constant on one side and a constant on the other. You could call it like, these really formal books on differential equations will be like C1, C2, and then they'll say C3 is C1 minus C2. We don't need to worry about that. We're not, it does, you'll see how these constants, when we do the next thing, it'll make a little more sense why we can just cancel them out like that. Okay, now I mentioned explicit solutions are better. Technically, this is the general solution, but I like to write things explicitly. Y is a function of X. So let's do that. This is technically -1 over Y equals T cubed over 3 plus C, right? And so to solve this, maybe I'll go to the other board here. I'm just going to solve for Y, right? Where's my, oh, here's my eraser. Let's put that there. Okay, so doing some quick, mine's not yet, quick algebra. Multiply both sides by Y, divide by all that stuff. What we end up with is Y equals -1 over T cubed over 3 plus C. Okay, now some more kind of crazy, weird differential equations algebra. I mean, it's the same algebra, but you'll see. This is also the solution, right? Now it's explicit, but I want to simplify it. I don't like complex fractions. And when I say a complex fraction, I mean a fraction within a fraction. I'm going to multiply by 3 over 3. I like this one. If you go to the back of the book, assuming this is a homework problem, you know, they'll probably write it like this. This is kind of like its most simple form here. Now, there's some weird stuff, right? Okay, this is making sense. -1 times 3 is -3, right? Nothing too strange there. What's T cubed over 3 times 3? T cubed, nothing strange there. What's C times 3? It should be 3C, right? Oh, 3C, yeah. But I put C here. The reason is it's just a constant, right? Kind of like before, you know, C2 minus C1 is C3. I could call this, you know, in a formal book, you would see this is C3 and this is C4. We're not going to worry too much about it, right? And then what was it? C3 and C1, it doesn't matter, right? They kind of like keep track of these things. But we're just going to call it C. It's fine, right? A constant times a number is still just a constant here. Okay, let me peek at my notes because I bet you I wrote something down that I didn't mention. Oh yes, there is. Okay. A couple things I want to mention. How do we check our work, right? Oh, you can use K, sure. Go for it. In the exam, use K. In written homework, use K. I think WAMAP, the online homework, you know, because it's like a computer and computers lack intelligence. I'm intelligent enough to know the difference between a C and a K. WAMAP might not, you know. So WAMAP will tell you what variable to use. I'm pretty sure it asks for C, but anyways. How do we, there's two things I want to look at. One, how do we check our work? And then two, I want to graph this and then look at something called an initial value problem. So checking our work. Now let's erase this. I don't do that anymore. Our differential equation was this guy, right? This guy. How do we know this is a solution? The way we check our work is this will get plugged in for y. I take the derivative of this and I plug it in for dy by dt. And the algebra should work out. Let's try it. This is a good one to practice because we have to plug in two things, a y and a dy by dt. Oh my goodness. I'm going to do this. This is also the same thing, right? -3, I just put this in the numerator with the -1. And the reason I did that is because you could take that derivative in a lot of different ways. You could do the quotient rule. I'm going to do the chain rule, right? We're going to do a lot of derivatives. Okay, so yeah, this is also a review of derivative rules. Derivative of the inside times the derivative of the outside. And then that constant here. So let's just do that. -3. I'm going to put two sets of parentheses here. If you have a different way of doing chain rule, that's fine. This is just kind of quick. Derivative of the inside, that's going to be 3t squared. Boom, right? 3t squared. Derivative of the outside, oh my gosh. Wow. Derivatives, I subtract 1 from the exponent. So what's this going to be? Is it going to be 0 or -2?
-2.
-2, that's right. Right, so this will become -2. And then what goes out front? A -1 goes out front, yeah. Yeah. -1, should have made this a little bigger. T cubed plus C. Did you say -2? I think you did, right? That's kind of what ends up going here. Let's simplify this. Negative and negative cancels, so that's 9t squared. Oh, maybe I'll do this. I'll just type it like this. 9t squared over t cubed plus c to the second power, right? I made that exponent, made the exponent positive here, right? Okay, then what we're going to do, take this, right? Take this and plug it in here. Take this and plug it in here. And everything should handy dandy work out. Oops. Well, that's okay. Our differential equation was this, right? Right. This is what we started with, right? And I'm going to do this. I like doing stuff like this. Cool. So then, you know, like, okay, so this is our derivative. I'm going to plug this guy right here. I got to figure out how to turn that doorbell off. I did turn off the waiting room. I did not know that, like, somehow over summer waiting room got enabled. Okay, so here's derivative. T, and then y was this guy. All right, let's see if this works out. You can move all the way over. Nothing really to simplify on the left that I can see, so I'm going to leave that alone. And on the right, I'm going to distribute the square, and look what happens. -3 squared is 9. And I distribute the square to this guy. And boom, I think these two sides are the same, right? 9 and 9, t squared and t squared, and the denominator is whatever those denominators are, right? So, cool. I'll put a smiley face. So that was fun. Cool. All right. So, what was the other thing I wanted to mention? I got a peek. You know, can't remember everything. Oh yeah. Let's do. There's 2 more things I want to look at here. Let's look at something called solving an initial value problem. So what's solving an initial value problem? I erased the original problem, but originally I had this written down. Blah, blah, blah. And then the instructions said, I believe, find the general solution. Right, to this, what time is it? Oh, we're good. To this differential equation. That's what we did. Now, I don't know where it went. Oh, it's over here, right? Whatever, it's that naked, this guy, right? I plugged it in. And notice the general solution always has a plus c, right? So, and that's gonna always happen. There's different values of c. You know, if c were equal to 5, still works out the same on each side, right? But c is kind of the general thing here. Now, an initial value problem is a little different. I'm going to write how you'll kind of see it in the homework and stuff here. Solve the IVP, where y of let's say 0. Let's say y of 1. Let's just do y of 1 to make it a little more fun. Equals 5. And I'm just going to copy our solution down. Here's the solution we got. I'm just copying it from over there. Cool, right? There's our thing. Now, an initial value problem is always something that has 2 steps. You first find the general solution, which is what we did here. And the initial value problem says, find the solution. This is kind of like I'm saying in words that's a little more Englishy, you know. Find the solution where it passes through t equals 1, y equals 5. And so what we're going to end up with is a particular solution, and we're going to end up solving for c, right? There's lots of different solutions. Vary C and you get a different, solution. IVPs are always like finding a solution, right? So kind of remember, always has a plus C. You got to solve for C for this guy here. And then we'll do like a little Mathematica dealio here. Okay, so here's kind of the thing. I hate this notation when doing IVPs because especially on an exam or something like that, stressful situation, I always accidentally plug y equals 1 and t equals 5. It's just like because the y is right there, it just looks like I should call y 1. But notice that t is y of t equals 5. So I like to do this every single time. T equals 1 and y equals 5, just to remind myself what gets plugged in where, right? Because it's just like blows my mind. Now, this is going to be 5 equals -3, 1 cubed plus c, right? And a lot of times, though, it's like y of 0 equals 5. That's why they're called initial value problems. Doesn't matter though, it could be anything. So yeah, we just solved for c. So let's see, what do we get? That's going to be c plus, oh, wow. Oh, wait, I can fix that. C plus 1 times 5 equals -3. C plus 1 equals -3 over 5. And just some quick algebra, C equals, oh man, -8/5. So the solution to the IVP is y of t equals -3 t cubed minus 8/5. Now, keep in mind, this comes up in WAMAP and on exams or what have you. Oh, it's kind of like, well, let's see, I'll do this like that. Does that help? A little less glare. Well, hold on. I'll work on that glare issue. Or maybe I'll put like something over that. But anyways, C is -8/5 right here. A lot of times what people do on WAMAP, this is where they get stuck, and you'll lose points on the exam. This is not the solution to the initial value problem. The equation is the solution to the initial value problem. So don't get those two things, like mixed up, right? Remember that this is the solution, not this guy. Okay, cool. So, okay, 10:38. We're on track. So I'm going to go to share screen. Oh, I got to open Mathematica. It closed on me. And just kind of real quick. Let's see, okay. Share. Oh, right. Cool. Okay. Yeah. Go to this camera so you're not like looking at my ear as much. Okay, now what I want to show you here is one other thing. You're going to want to, and I'll send an email about this on Canvas after class today. What I just loaded here, some people might be familiar with the Seattle Central package, which is just like a little Mathematica add-on thingy that kind of just shortcuts a lot of graphing features, right? So like Axis 3D, maybe you've seen it in your Calc 3 class or something. It just plots a 3D axis for you. That's pretty easy. We're going to be using it quite a bit. Slope field, Runge Kutta, some of these other ones. Oh, DE system solver, DE solver, direction field, and Euler. We're going to use all of those quite a bit. And I'm going to send after class a little thing on how to install it on your computer. Because you'll definitely, you actually don't need it, but it's definitely super helpful. Okay, so let me get my little demo here. Oh yeah, here's what we're going to type. Okay, so I just want to kind of show you real quick. Manipulate. Wait, t squared, t cubed. That was our solution. What did I pick? Yeah, -525. Do that. Okay, cool. Mathematica thinks for a second. Sometimes not. Oh my God, wait. Please move this window. Okay. I don't know what was happening there. So here we go. What I've done is, okay, equation plot, right? We're just graphing our solution. And this manipulate, I like these manipulates a lot. We'll see them a bunch this quarter. What I've done is I've said, hey, manipulate this variable C, where now I have a slider bar, right? That just kind of moves around, right? And so these are, oh, maybe I'll move it down. These are all the different solutions for different values of C. Now, the thing I did yesterday just shifted it up and down. But notice this guy kind of just moves the asymptote for different values of C. We can plug in ours, -8/5. And here we go. And notice y of 1 equals 5, right? I should be able to put a point there. I'll skip it, right? But you could put plot a point right there and see that y1 equals 5, right? So our value of C equals -8/5 fit the initial condition, right? For this guy. Whoa. Shook this whole room up here for a second. Okay. All right, let's get out of the share screen and go back to this other camera here. Go to, ta-da, I'm back, right, to this camera. Okay, I don't want to do this one. This one takes, I know this one's like the longer one. Oh, yeah, you have to like solve the quadratic formula for this guy. Okay, this one takes a minute. We only have like 10 minutes. Okay, let's look at this one. This one is quick and super important, and we have like 5 minutes. I'm going to solve this IVP pretty quick. Or actually, how much time do we have? We have 5 minutes. I'm going to put this one up here. I'll say find the general solution. dy by dt equals y. Right? This is the differential equation. And what I'm going to do is throw you all into the breakout rooms. I'll try and float around to the different breakout rooms and talk about, solving it. Algebraically pretty simple, but just for the last few minutes here. Okay, let's see, how do I breakout rooms? And I'm just going to do random ones, groups of, let's do groups of 5. Boom. All right, you all have been invited to your breakout room. I'll like jump into these rooms here. Oh, I'll pause the record. In myself, and then switch to the other camera. Cool. Well, hello. I think the breakout rooms are busted up here. Hopefully you all kind of like had some time to look at it. I'll just kind of walk through really quick and show a little bit about the exponential stuff or the weird algebra that goes along with this. The way you separate this is 1 over y dy equals dt, right? That's our separation of variables. We integrate both sides. This side is t plus c. This side is natural log, technically, absolute value of y, right? Because of time, I'm going to skip the absolute value. I'll talk about that tomorrow. For now, I'm just going to like kind of ignore it for a moment. Absolute value, I'm just going to get rid of it. Tomorrow, we'll see why we can get rid of it. It's just kind of time's sake. E to the t plus c. And then notice there's a algebraic simplification. And we can end up with our solution, I'll just put it over here, is y equals c e to the t, right? Now notice, e to the c is just e to the c, right? It's just a number. And so that just becomes another constant, right? E to the c is, it's like that thing, c1 and c2. It doesn't really matter. c2 is e to the c1, but we don't really care. Right. And, I didn't mention this one last thing, going back to this initial value problem situation, right? That's why it doesn't really matter when we combine constants anyways, right? We're just looking for this IVP. I just solved for this constant right here, -8/5. You could leave all those other constants in there and blah, 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 but it doesn't matter because this is what you're looking for, not this guy. And whenever you plug this back in, this is our solution, right? So the equation is the solution. It doesn't matter if you could have left this as e to the c and you just solve for a different c when you do the IVP, and then you just have to do another algebraic step. So it's kind of a moot point. All right, well that was fun. Let's see. Oh, do we have I see a chat thing here. The reading assignments do not have unlimited attempts. Reading assignments, you should be able to get through those looking at the book, and kind of like a lot of times they're just like read the book and answer that question there. But the online homework, you have unlimited attempts for that one. Now tomorrow, I mentioned this on Canvas message. Tomorrow, it's like not an official class time, but like 3 hours a week of lectures probably is not enough for this class. So tomorrow is the like optional kind of rally. We'll be going from 10 to 12. I got a message from several people. I guess a lot of you are in linear algebra. Say something if you're in linear algebra. I saw a couple hands. All right. Yeah. Woo. All right. Cool. So I don't know who's teaching linear algebra. Is it TestFi? Is TestFi teaching linear algebra? Who's teaching linear algebra?
You teach me at in math 142.
It's Ellingston.
Oh, Ellington. Oh, 142. Wait, someone's in 142. Oh, same. Yeah. Okay, yeah, Ellington is teaching earlier, so he's cool. But yeah, I heard a lot of you were there, so I'll do the 2-hour thing from 10 to 12. Not required, but always encouraged, because, I'll do some breakout room stuff, and, the more you can talk to me, the better. I'll probably do, because it's 2 hours, like a 5-minute break in between. But regardless, it will get posted to Panopto, just like this, right? This will also be posted to Panopto. All right. Well, it was good seeing you all. And maybe I'll see you tomorrow or otherwise Monday. And see you then. And also, question?
Yeah. I had hello. I had a question about the reading that was due this morning. Is that due?
Yeah, I'll push, because it's beginning of the quarter. I'm gonna, after class, I think, move the reading assignment that was today. I'll move that to tomorrow, because maybe some confusion about that being due. So I'll move that one and send that thing about downloading the package. So if you didn't get that done, that should be okay.
Okay, thank you.
Yep. All right. Otherwise, see you later. And
I have a question, sorry.
right? And I'll just hit